So here we're given our equation. Since our x is first, we know we open sideways in the x direction. There's nothing being subtracted to your x's or your y's before you do your squaring, so you know you're centered at the origin. So your a is what's underneath your x's. So a is 3, so you got to go 3 units to the right, 3 units to the left. Your b squared is what's underneath the y's. So you get b to be 5. So you go 5 units up, 5 units down. So now that you have those red dots, you then need to go ahead and draw a horizontal line going through at -5, horizontal line going through at +5, vertical line going up and down at 3, and a vertical line going up and down at -3. That then forms a box. You then want to draw these dotted lines going through the corners of your box, going through the center also. And then you want to do this one here, going through the other corners. Those are the asymptotes. Those are the two dotted lines that your graph gets close to as it goes out far to the right and far to the left. Now, since you would know you are opening to the right and to the left, you would take this point here and then draw a smooth curve going off to the right and getting closer to that asymptote. And a smooth curve here going off to the right, getting closer to that asymptote. Same idea over here, and that's how we end up getting the blue graph. Your vertices there are when your hyperbola touches your box. Those are the pink ones, so you're going to be at ±3, 0. And we already talked about drawing your box. Now, your C value, your foci, then is basically your Pythagorean theorem. And you get ±√34, which is just a little bit less than 6. So you're going to go a little less than 6 units to the right, a little less than 6 units to the left. Those are your foci going from your center, which is 0, 0. So then we get our foci to be ±√34, 0. Your vertices we talked about. Now, your asymptotes you'll also want to go ahead and find. Those are just the equations of your green dotted lines. Well, you're centered at the origin, so you know your y-intercept is 0. In this case, for your slope of the one going this way, you go up 5/3, so you got a slope of +5/3. Here, for your other one, you go up 5 to the left 3, which is a slope of -5/3, so your asymptotes are ±5/3, x. Well, here you're given some information. You got to work backwards to find your hyperbola. So you have your foci, you have your vertices. So plot them on the graph. Since your vertices and your foci are on a horizontal line, you know you're going to be opening sideways in the x direction. So that's why we have this standard form for the x opening in the x direction down here. Now, halfway in between your vertices is this point. So you know that's your center. So in this case, your center is at the origin. Your vertices are 5 units to the right, so you know A is 5. Your foci are 8 units away, so you know C is 8. So you can use your Pythagorean theorem to work backwards to find B, and then you get B squared, or B to be √39. So then we want to come along and plug that in. Plug in our A, which we said was 5, so you get a 5 squared. Plug in your B, which was √39, all squared equals your 1. So you get 25 there, and you get 39 there in the bottom of that one. So that would be your equation. Circles. You guys should remember, we've talked about this before, the standard form of an equation of a circle. H and K is your center, with R being your radius. Once again, if it's not in the standard form, you'd have to complete the square to get it there. So now you need to identify what each one of these is. Well, when I look at the first one, I see a y squared, but I don't see any x's squared. The only one that doesn't have both of them being squared are your parabolas. So the first one has to be a parabola. When I look at the next three, I know I have x's squared and y's squared, both. So I know they either have to be a circle, an ellipse, or a hyperbola. Well, if I go ahead and take a look at this next one here, well, actually the next two, to be able to really tell, I need to be able to get my x's and y's on the same side. So to do that, I'm going to go ahead and take my x squared to the left side by subtracting. So I get a 7y squared minus a 7x squared equals my 14 over 3. So automatically I know, since I have two squareds and they're being subtracted, it then has to be the hyperbola that we just talked about. When we take a look at the next one here, we got to get our x's and our y's on the same side. So I'm going to go ahead and take my x's over to the right side. I'll get a 4. That's a 4. I don't know what happened there. Plus my y squared. Now I want to take my 25 to the other side. I now know that since I have an x and a y squared, it's a circle and an ellipse. Same thing down here. X and y are squared, so it's a circle and an ellipse. But since they're added and the number in front of my squareds is both the same, it has to be a circle. If the numbers in front of my added variables was different, then it would be an ellipse. Here it talks about the reflexive property of hyperbolas. So you may want to go ahead and read through this, as it'll give you some insight into why we're studying parabolas, because there is real life application to it.